In Lesson 5, we're going to look at the difference between proportional and non-proportional relationships in graphs. Isaiah sold candy bars to help raise money for his scouting troop, and the table shows the amount of candy he sold to the money he received. What we want to do is find out whether this is a proportional relationship, and knowing what we know about tables to this point, we know that we have to have the same rate in each entry in order for it to be a proportional relationship. So when he sold 2 candy bars, he received $3. We would divide 3 by 2 to find out what the rate is, and that is $1.50 per candy bar. So next we need to go to the second entry and see what the rate is if he sells 4 candy bars and receives $5. 5 divided by 4 is $1.25, which is clearly not the same as $1.50. So at this point, we already know that this is not a proportional relationship because the rate must be the same for every entry in order for it to be a proportional relationship. To take this table and to put it on the graph, we would be graphing those same values, 2 and 3, 4 and 5, 8 and 9, and 12 and 12. Our x values, remember, go across and our y values go up. So for the first entry, we would go across 2 and up 3. And you'll put a point on the graph right there. On the next entry, we'd go across 4 and up 5, and then put your point in. And continue with that. Connect the dots when you're done in a line, if that is possible. Characteristics of graphs of proportional relationships, there are 2. The first one is that proportional relationships make a straight line. And the second quality is that that straight line will pass through the origin. And the origin is 0, 0 on the coordinate plane. It would be right down here in the corner because we are looking at only quadrant 1 right now. There are 4 quadrants. We're only looking at quadrant 1 at the moment. So those 2 qualities have to be in the graph in order for it to show a proportional relationship. Following those guidelines, you're going to graph the x and y coordinates or ordered pairs for each of these relationships and then use a straight edge to try to connect in a line and check to see whether it's going to pass through the origin and whether it is a straight line or not. You'll compare example 2 and example 3 to find out if they have some similarities. For example, are they both passing through the origin or are they not? Are they straight lines or are they not? Remember, for it to be a proportional relationship, it must first of all make a straight line and second of all pass through the origin. So although you may find relationships that create a straight line, if they don't pass through the origin, they are not proportional. Please continue on with the problem set once you have done that.